What we're going to do today is talk about equations as functions. And you've heard me slip and call these functions in class before, and that's because for my other two classes that I teach, we talk about them as functions. So we're going to work on finding the value of a function at a point, and we are going to work on graphing these functions. So something that's a little bit different is the function notation. Instead of y equals, what we have is we have f of x, and that's what you're going to say. Say f of x. That's how we say that. And if I was in class, you know that we'd be saying this so many times until everyone participated, so say it all together, f of x. You better have said it. All right. So what you're going to do is this is the same thing as y. On the warm-up, you had the equation y equals negative 3x minus 4. In function notation, we write it as f of x equals negative 3x minus 4. And function notation really reinforces what the input is. And that's what you've got down below. Y equals 3x plus 7 is the same as f of x equals f3x plus 7. So f of x just gets replaced instead of y. And this is still our equation. Now if you take a look at the function notation versus what this is, it says f of 2. So I have a 2 here instead of x. That means every time I see an x in the function, I'm going to plug in the number 2. So just like we did with the tables, the equation stays the same, 3 times something plus 7. And our something that we're going to be plugging in is the number that the function is of, which is 2. So 2 is going to go in where x was. So that gives us 6 plus 7. So we can say f of 2 equals 13, because 6 plus 7 is 13. So now instead of making a table with x and y, we're going to make a table with x and f of x. There are also some other possibilities that you're going to see here. Instead of x, they could use h of x is equal to 3x plus 7, and that just might mean that that's the height of something. They could use r of t. R sometimes stands for the rate of things, and t is the variable, so t is the variable in our equation. They could use c of r. Any combination of your two initials might be used in here to rewrite it. The ones they're probably not going to use is o of x, for the same reason we don't let o equal a variable. And the other one that they might not use is L of x, because most people's L's are not fancy like mine, but they just look like the number 1. So most of the time we do not use those. So let's take a look at some function notation. And we're going to do this tricky one first. I have f of x equals x squared minus 2x. Now, this particular equation looks a little bit different than the other ones that we've done the past couple days because of this exponent right here. The exponent on there tells me that it's not going to be a line. The ones that we've all looked at the last couple days have had exponents of x to the first power, so this is not going to be a line. We have our input, which is our domain, that's still x, and we have an x twice in my equation. So when we're plugging in numbers, this says f of 2, I'm going to leave that placeholder and just put the shell like I did on the warm-up. And you can go ahead and do that for all of these. The shell of the equation is not going to change. The only stuff that's going to change is what I highlighted. These are next to each other. That means multiplication. I got super excited. I already filled that one in for us. And we're going to go ahead and plug those numbers in. For f of 2, I'm putting 2 in for x. So 2 squared minus 2 times 2. 2 squared is 2 times 2, which is 4, minus 2 times 2, which is 4, and that gives me 0. Next one is f of negative 1, so I'm plugging in negative 1. So negative 1 squared means negative 1 times negative 1, and a negative times a negative is a positive. So I've got minus 2 times a negative 1. Well, that's 2 negatives being multiplied. So that becomes a positive 2, which gives me 3. Plugging in 3 next, since that's what f is of. F of 3 is equal to 3 squared minus 2 times 3. 3 squared is 9. Minus 2 times 3 is 6. So that's 3. And f of 0 is 0 squared minus 2 times 0. And 0 minus 0 is still 0. F of positive 1 is 1 squared minus 2 times 1. 1 squared is 1 minus 2. That gives me negative 1. So I'm going to graph all of these. Input, output, input, output. Other vocabulary we've used, domain, range, domain, range, domain, input is 1, output is negative 1. And we're just going to go ahead and graph our points. Negative 1, 3, 3, 3, so 1, 2, 3, 1, 2, 3. I've got 0, 0, and we've got the point 1, negative 1. So what this looks like is this upside down, or this U, which we call a parabola. All right. Here is the next problem, and it says given f of x is equal to 3x minus 2. This one would be linear. It would be a line because it's an x to the first power. It says find the range for the given domain. And the range, that's our output. That's our y value, and in this case, that's our f of x value in function notation. So if our domain is negative 2, 3, and 5, I need to find those three values. F of negative 2, f of 3, and f of 5. I can go ahead and fill out the shell of the equation. The thing that's going to change is our x value. The other stuff is not going to change. And 3 is being multiplied by x, so I'm going to show that in parentheses. 3 times something minus 2. 3 times something minus 2. The equation doesn't change. What we change is what we plug in. So this one we're plugging in negative 2. Multiplication goes first. So we're going to multiply 3 times negative 2. So we get negative 6 minus 2 is negative 8. And then we've got f of 3. So 3 times 3 is 9 minus 2, which is 7. and 5 gets plugged in last. So 3 times 5 is 15, minus 2, following our orders of operation, and that gives us 13. So it asked for the range, so our range we list from least to greatest, and that range is -8, 7, and 13, and that is in the order from least to greatest, and we only list our entries once if we would have a repeat. And there we go. So the sub's going to be passing out your worksheet that's going to be for your homework. So if you have questions, please stop into the Math Study Hall, and the Math Study Hall teacher will be able to help you out. I hope you have a wonderful weekend, and I will see you on Monday.